can you confirm if you can see my screen?
Yeah, it's loading. Yes, it's up now. You can see.
Okay. So thank you so much for the opportunity to really be part of this year's AI bootcamp with our friends Data Science Nigeria, whom we are working very closely in order to advance the use of GIS and other geospatial analytics, to address critical challenges in various sectors of the economy. So over the next few minutes, I'm going to take you through, what Grid3 means, and also from the global level coming down to the country level, and also subnational level to fully understand what we do and how we relate with the AI space in country, and also how we contribute in terms of providing core-fundamental geospatial data layers, in order to come up with various use cases to address critical challenges, like I mentioned earlier, across various sectors. So Grid3 is a program that strengthens, geospatial data availability across various countries. We work with governments, we work with relevant partners and donors in order to make available this geospatial data layers, to address our sustainable development issues. And in addition to that, we work with an efficient innovations, and also finding an optimized or maybe optimize the resources to really ensure that everyone, is on the map in terms of, sustainable development, in terms of equitable distribution of income, equitable distribution of resources, distribution of health-related commodities as well. At the global level, Grid3 has mapped, various countries in which we generated, or we currently, host over 15 million settlement points. This is across 48 countries in Africa. And this is involving field data collection, involving, data, aggregation from various MDAs, from various governments, private sector, as well as development partners. And we also currently have over 62,000 health facilities, which is cutting across DRC, Democratic Republic of Congo, Nigeria, and Zambia. Nigeria alone hosts over 40,000 of these health facilities. And these are locations of health facilities with their name, functionality, as well as ownership. Does it owned by government, private sector, and at what level of care? Is it at the federal level, state level, local government level, or at the ward level, which is basically the primary healthcare centers and facilities? Going down to schools, we also currently have, over 116,000 locations of schools. And these are primary, secondary, and tertiary schools. And these are schools that also, indicate their functionalities and their level of ownership as well. Are they being owned by private sector or the public sector? And at some point, we go deep down to really assess, the quality of these schools in our collaboration with Universal Basic Education Commission, particularly in Nigeria and other, countries such as Zambia, to really determine the locations of the schools, and also to really determine, their functionality in terms of addressing critical challenges to school access. When we talk about point of interest, which are basically POIs, these are other points that are really very important to sustainable development planning, and to also aid in terms of administrative planning at every administrative unit, be it at the ward level, local government level, state level, or even at district level compared to other countries. So this includes locations of, farmlands, locations of markets, locations of water points, locations of dump sites, heavily related to every, sector that you intend to deep dive into, generating AI models and machine learning algorithms. When you go into boundaries, we are all aware, or some of us may be aware, that we have different boundary sources in Nigeria. And this is also the same issue applicable to other African countries. But in Nigeria particularly, we do have various boundary sources, especially when we talk about ward boundaries. You have boundaries generated by the National Population Commission, which they use them, to conduct elections. To conduct census. You have boundaries from the Independent National Electoral Commission, that's INEC, which they use them in order to conduct, elections. You do also have other boundaries, especially being used by the National Primary Health Care in order to address polio, program, or in order to use it for micro planning and other primary healthcare related interventions. So across these 48 countries, we currently have over 45,000 different boundary sources. This is level 1, level 2, and level 3 administrative boundaries within Africa. So these data sets are not just only there, but freely accessible through the Grid3 Data Hub. As you can see, this is currently the data hub for Grid3, which is basically providing free access to the huge number of, or huge thousands of data sets across the 48 African countries. And this ranges between the boundaries, the infrastructure, which are basically the POIs, the population estimates, settlement extent, settlement points, and other relevant data set. And these are freely accessible at data.grid3.org. So these different data sets, like I mentioned, are freely downloadable in different formats, depending on the tool and applications that you're using in order to conduct your analysis or to conduct your geospatial data analytics. And this also intends to provide you further access or further training in terms of accessibility to those data sets, and as you navigate into the Grid3 Data Hub. When we come to the country level, specifically for us as Nigeria, we currently host 4 co-fundamental geospatial data layers. And the first is the Grid Population Estimate, version 2.0. This is a bottom-up approach, population modeling, which is being used to estimate or predict populations of where people live at 100 meter by 100 meter grid cells. And it is the highest resolution of population estimate you can get, in the country, which is being used to plan for different interventions, be it in the health space, be it in the education space, agriculture, and other critical sector. And it is freely accessible through either the Grid3 Data Hub or the Grid3 Nigeria data portal, which I will show you in my subsequent slides. And this population model update is being used, or it was jointly generated by the National Population Commission. So it provides that kind of country ownership, which we can fully rely on, for our geospatial data analysis, for our models, AI and machine learning algorithms, which will help us to generate insights across, different interventions. By the right-hand side, we have the settlement extent, which is also version 2.0, as we're currently working on generating new versions. It tells us locations of where people live, based on building footprints. We have different building footprints, which tells us, residential and non-residential buildings, and which will fall into our, analysis and planning in order to really optimize, resources. The next data layer is the administrative boundaries. We have currently administrative boundaries at the LG and ward level. So the LG level boundary is what is being managed and published by the Office of the Surveyor General of the Federation, that's OSGov. However, through the Grid3, we do currently have also operational boundaries for operational users in terms of granular planning and granular estimation that we intend to do. And this is also freely accessible. And the other POIs, like I mentioned, are also the fourth data layer that we currently have, which is going to be freely accessible to you and also to other users at all levels, both national, state, as well as local government levels. Like I mentioned, the country-specific access to that for the different data layers is the Grid3 Nigeria data portal, which is available at grid3.gov.ng. The site is currently undergoing a maintenance by the National Space Research and Development Agency, NASDA, being the custodian for the data portal. However, you can access, this data set across the 36 states plus the FCT, depending on the availability of data, depending on the areas of interest that you have to access these geospatial data layers are all available across the 36 states. Other data set that intends to determine or that intends to, provide information on maybe health status or any confidential information that is strictly, based on requests. So it's not really public as it relates to other sensitive information. As we go further, this slide or this section will tell us how these data sets are being used and how they are applicable to our sustainable development and how we can apply them in the AI space. But before then, it's really important to kind of ask the question or respond to the question of what is GIS. Some people still, think about GIS as a rocket science, or it entails a huge, technology that is going to be very difficult for a layman to understand. But that's not true. So GIS basically means Geographic Information System, even though there are several definitions, but is a database combined with, visual map interface. And it is being used to analyze objects, especially in terms of locations of where, things have happened, and also used with any data that can be geographically tagged. So that is the simple, definition of what GIS means. And in terms of relating that to the AI system, there is a very strong connect between GIS or geospatial data and artificial intelligence and machine learning algorithms, because now a lot of developed countries, like the previous speaker had mentioned, have gone far into, delving into this space and coming up with so many solutions to addressing our major challenges. There are a lot of challenges that, are AI-based, that needs AI-based solutions, and which, of course, we're still trying to come up with. And credit to DSN, doing a lot of work in terms of sensitizations, in terms of advocacies, in terms of training, capacity building, for AI in Nigeria. And they are also very strong advocates of integrating geospatial data into the AI space. So this, contain a wealth of experience, a wealth of information class into various geographical locations. And there are a lot of AI systems that leverage geospatial data. And GIS can thus add value, to AI, like I mentioned, by providing rich data sets. As you can see in Nigeria, we do have this comprehensive data set, but what skills do we need to really help this to put it into the pipeline for AI analytics, to address our key challenges? Also, other questions around this involve identification of where locations is, or what is the name of a particular location in terms of geographic information. Where are the public health facilities? Where are the schools? So AI will tell you, will not only, if GIS tells you where are the schools or where are the public health facilities, then AI will go deep dive to tell you some insights. How do people visit those schools or those health facilities? Do children go to schools? Yes or no? So also we talked about network analysis, the shortest walking routes between different points, modeling scenarios, what will be the effect on the river water quality if population doubled, spatial analysis, are there patterns in building footprints which suggest residential, commercial and other uses, change analysis, where do we have new homes to be built in order to address housing challenges in a particular population. Further AI models that have been used in the previous COVID-19 response, Grid3 worked with Frame. Maybe some of you may know Frame. They are into deep learning, they're into AI and machine learning, and they utilize the Grid3 data to come up with these different risk layers, exposure, populations that are exposed to density or population proximity to households, sanitation, populations that are vulnerable in terms of facility access, as well as use, and also communication access, whom have not been hearing about any information about how to solve their issues on access to media in order to hear about preventive health recommendations for COVID-19. Socioeconomic vulnerability, those populations that need support, that are socioeconomic vulnerable, that are significantly affected by the economic shocks as a result of COVID-19 pandemic. It also tells us about population that have other pre-existing health conditions, so that when they got infected with COVID, it's going to be very severe than those without those pre-existing health conditions. And this is how this risk layers tells us about visualizing the whole country. The darker the colors, as you can see from both maps for the health facility access and for the socioeconomic vulnerability, you can tell which population are very vulnerable or that are risk, which we can provide policy decisions, or we can provide policy recommendations on how you can respond to those populations. This also tells us about the comorbidities, the communication access, where we can go in and respond to that. So there are also a couple of other applications which I will quickly show us in education and health that are freely available, which we can leverage for other AI models. For education, this is a tool. I think is it last year or 2 years bootcamp, 2 years ago, we show an analysis similar to this, which tells us the places where there are supposed to be schools, but there are no schools. And if we intend to address out-of-school children, this is a typical, analysis that we can use in order to tell us where do we need to situate or locate new schools in order to address out-of-school children. And this is an example in Kano State. The blue colors tells us the dark blue colors tells us the current locations of existing primary and junior secondary schools in Kano, and the red points indicate locations where there are supposed to be schools, so as to address the rule of thumb for UBEC that no child should travel more than 2 kilometers in order to access a school. And it also tells us the current number of schools in the state. This is based on UBEC National Personal Audit Data 2018. Of course, with the new update of the data, these statistics may change, but the central to this analysis is to tell us where do we need to have, new schools? And this is an example that we can, leverage and rely on in order to, use those geospatial data layers, like I mentioned earlier, to come up with these various case scenarios in order to address our challenges. In terms of health, we've been engaged in various analysis which addresses how resources should be distributed, how vaccines should be distributed in order to reach the last mile population. And this is an example of a world map that indicates optimized locations where you need to see or where you need to have more people that vaccinators can reach in order to provide the different vaccines that they have. This is an example from a measles campaign in Kano, and it tells us, locations for health facilities, as we can see by the box indicating one. That's a locations of a health facility, cycle with the pink buffer. And it tells us more information around the population that are within those places, and we can clearly see the different features, on the map. This includes health facility locations. It includes primary schools locations. It includes markets. It includes, population distribution and index, which will tell us, where we need to find more people and where we need to prioritize in terms of the vaccines distribution. This is another example which also use an optimization model. The optimization model uses the data to come up with optimized locations where best you can reach population. In COVID-19, when the COVID-19 vaccine arrived Nigeria, and a lot of people were not accepting those vaccines. And, we tend to not really, they don't accept the approach that we need to deploy in order to reach those populations. And we use this analysis to, indicate or show to health workers where people mostly live and where you need to straight your vaccination points, your vaccination site, where you can reach more population. And once people see those vaccines, it's available here. I don't need to go far. I don't need to go to a particular health facility or a particular location. I can freely access it here. And it tells us at a state level or at the national level in the first place, how many vaccination sites are needed in order to reach more populations based on the different priorities. So we categorize this into three priorities. Priority one, targeting populations that are 50,000 and above. Priority two, targeting population that are, 10,000 to 49,900. And priority three, targeting population from 1,000 to nearly 10,000. So this, based on the different priorities, for priority one, we're suggesting 102 vaccination sites for the whole country. For priority two, we are suggesting 998 vaccination sites. And for priority three, we are suggesting over 24,900 vaccination sites, which will help to reach more populations. This is a typical example that you can leverage the geospatial data for the AI models. So this is my summary slides, which is leveraging or copying from a roundtable we had sometime last year with the University College London in terms of what are the key challenges or what are the opportunities for AI, artificial intelligence using geospatial data. And I'm summarizing my presentation with these key recommendations based on the output of our roundtable. The first is the issue of data standardization. A major challenge we've identified in this space is that a major challenge to the widespread, adoption of AI is lack of standardization, integration, and availability of data. And I also like to put this credit to the data science team, working, vigorously in terms of generating a lot of data set through various sources, crowdsourcing, field data collection, and also other sources from various stakeholders in order to make them fully available for stakeholders like you, to use for AI models. The second issue is automation. Automation of the way in which datasets are brought together will assist in making informed predictions about future events. And this is an example. If we look at COVID-19, how do we automate this process to tell us future events in order to prevent another pandemic in the future, for example? The other, key theme is the data streams. There are multiple streams of data that feed into decision making, determining which datasets are appropriate to inform decisions, and also understanding the aim of decisions is crucial if AI is to be used, effectively. And this is also very critical in terms of differentiating or addressing these different data streams that are floating by various stakeholders. The last point is the organizational alignment. Alignment between organizations and interdisciplinary approaches are key for ensuring that data are used ethically and democratically. For example, if we talk about health, how do we, even within health space, when we talk about immunization, how do we, leverage different organizational alignment? There are different players working in the space. So collaboration is really very key in this space. How do you collaborate? How do you share insights? How do you share learnings in order to improve for the adoption of AI in Nigeria and beyond? So thank you so much, and I look forward to questions over the next few minutes. Thank you, and over.
Thank you very much, Nazir. Can we appreciate Nazir once again? Thank you for your time. Please confirm that you can hear me, Nazir.
Yes, I can hear you.
Okay, thank you very much. It's been a very loaded session. So I don't know if you have questions before we move to the next session. I think. Okay, so before we go for lunch, but I don't know if you have any question for Nazir before she leaves. Sorry, before he leaves, rather. So, some of the pictures, in time past, like Nazir said, Grid3 has been a friend of the house for time past. You have a question, right? Okay, so can we take your question? Say it, then I'll help with it. Mm, okay. Yeah, the data sets, yeah. Okay. So Nazir, I'm sure you didn't hear that, so I can try and echo what he said. Okay, so
Okay.
he's saying that it's been a lovely presentation and they appreciate that that's one of our participants on site. So he's saying that can we have how to access some of these data sets that they never knew that existed in time past? So how are they able to access it from the public domain, right? Is that what you said, right? Yeah, so how are they able to access this data?
Okay, do you want me to respond or get other questions? Then I can respond at once.
Okay, so any other question? I think we can take that as maybe the only question here for now.
Okay. I think I had this in my previous slide. So for the country-specific data, you can access it through grid3.gov.ng. But like I mentioned, this portal is currently under maintenance by National Space Research and Development Agency, NASDA, and is going to be up and running in the coming weeks. That's the country-specific portal, and this is, accessing data for all the 36 states plus the FCT. And however, you can also access the country-level data from the Grid3 Data Hub, which is at data.grid3.org. And this will also give you access to all the country data sets. So once you visit the site, it will show you a landing page, like this, but you have to scroll up. Then you go and click Nigeria, and it will show you whether you want to visualize the data on a map or you want to go directly to the data catalog where you will download the specific points or data set that you need. So that's where you can access the data currently.
Thank you very much, Nazir. Is that clear? Ahmad, so is that clear? Thank you very much. I think we have one more question. Yes. Okay, so maybe I can echo the question. So the
Please.
question is, do you have a repository where you use the application of AI as regards some of these data sets that you have? I mean, talking about how are you able to aggregate the data, how are you able to structure the data. So like it's trying to look at the process of how you arrive at those data aggregation, data structuring. You know what we have is the structured data at the end of it, right? So
Yeah.
is saying, are we able to? Is there a step or a process that shows how you're able to structure those data from the point of collection to the structured data where you get to have the final data for usage?
Yeah, so we deploy different methodologies to do that based on the different data set that we have. For example, for the population estimates, this is a model population that we update when national coverage data set are available through our partners at WorldPop in the University of Southampton. And once those country level data set are available, such as, covariates, sensors, new sensors data, new micro sensors, new national surveys, we use that to update the model, we use that to update the population model, which gives us the greater population estimate at 100 meter by 100 meter grid cells. When you talk about the settlement layer, we update the settlement extents, when new data sets are available. We currently leverage the Maxa building footprint, Maxa building footprint, which we use it to generate the settlement extents with our partners at Columbia University Center for International Earth Science Information Network season. The other data points, for example, the boundary data sets, these are also based on what countries made available in terms of the validated boundaries. Grid3 leverage the country-specific data, and we work with various government agencies to leverage those available data set that they have. In terms of other, repository for where you have our AI models or maybe analytics and all that, we don't really directly have like a repository where we have that. However, our partners use the data to come up with the AI models, to come up with those analytics. An example is DSN, right? So, and there are a couple of other partners that use that, but we mainly ensure that we provide very clean and quality geospatial data that can feed into the models that the AI stakeholders in the space can use.
Thank you very much, Nazir. I think that's very clear. Maybe I can echo that again. What Grid3 does is making sure that we have the usable data, right? In terms of developing models, getting to make use of those usable data. These are some of things that we do at DSN and maybe like other partners that Nazir just said. So in terms of cleaning the data and the process, they're just similar to some of the things that you've been going through. I mean, all before now. How do you get to collect your data? How do you get to structure your data? So Grid3 is just a very unifying partner that helps to take care of all of those processes. So I don't know if that speaks or answers your question. So thank you very much. Thank you very much, Nazir, for that clarification. So any other question before we go? Do we have any question online, Tedimola? Yeah, okay. I think that clarifies so very much. So thank you very much, Nazir, for your time. We really appreciate and cherish the partnership. Like I said, everybody that we've had on the call today, they are strategic partners of DSN, and we are glad to have you join us, especially in terms of mentoring and taking the participants on the importance of geospatial data. So thank you very much once again, Nazir, and
Yeah,
we appreciate having you. So do have a lovely day. Thank you. Thank
thank
you.
you so much.